So let's look at these exponent laws here, okay? You got this question, and we've written is 12k squared m to the power of 8 divided by 4k to some power m to the power of 5. First of all, k's to what power here?
1.
That's right, there is a 1 there, even though they don't write it in, okay? Now what we're going to do is we're going to write it like a fraction so we can line up our like terms. So we have 12k squared m8. And then, because division is the same as a fraction, I'm going to put my coefficients, which are the numbers, underneath each other, the k's underneath each other, and this time I'm going to write the 1 in, because there is a 1 there, and m to the 5. And this way, we can use our exponent laws, which I think you remember them all. If not, you can always go back and take a look, right? We can line them up. So we know we're going to be working with these, which are our coefficients. These are our k's. And these are m's. These are the only like terms. We can't do anything in between them. We can't like simplify this way or that way because those aren't like terms. The bases aren't the same. So the very first term says 12 divided by 4. Do you know what that would give us?
3.
3. The second one, it's k to the power of 2 divided by k to the power of 1. We subtract the number on top from the one from the bottom. So we'd get k to what?
To the power of 1.
Yeah. Do we have to write the 1 in?
No.
No, we don't have to. We can. And then the last one, with 8 subtract the 5, so we'd get m
to the power of 3.
Excellent.
Oh, so that's
it. That's the answer. The second question they gave you, here's another one. Negative x, I'm going to do the third one actually. 2 and then cubed on the outside multiplied by 3x squared squared. Okay, this one can be a little confusing too. First off, we have a power of a power. Okay? So instead of working with what we have here, I'm going to deal with those powers of a power first. And this multiplication sign, this extra x drawn in with our variable x, makes this confusing. So what I'm going to do is I'm going to represent multiplication by just putting the brackets beside each other. That will simplify the question a little for me. Okay? So right off the bat, I go x, or negative x squared cubed, and then 3x squared squared. All right? Already I notice less x's. This is a little simpler to look at. For bed mass, we're going to deal with our brackets first. Well, I can't really get any simpler than this. But the next thing I do want to do is I want to bring my powers of a power. And for that rule, we multiply the two powers together. So in the first one, this becomes negative x and then 2 times 3.
Yeah.
Okay. So that's right here. Now in this one, because there's a coefficient, and we didn't mention it in this one because it's not going to affect it much, but I should have. Because there's this coefficient, when we bring this 2 in, it has to go to both numbers. And the reason being is because really what this says is power of 2 is 3x squared times 3x squared. So those 3's need to be multiplied by each other. Now because this one was cubed, this is technically a negative 1. And negative 1 to the power of 3 is still going to be negative 1. So we didn't really talk about that, but it is very important that we do notice that. So really this will now become 3 squared, and this will become x2 times 2. Okay? So let's write this number in here and put the cube to it anyways.
Why would the 3 be squared?
Because think of it like this. Okay? This entire term here, I'm going to do it on the side. 3x squared squared. Well, what that means is you take the base, and this whole thing is the base here, and you multiply it by itself 2 times. So I'll write that in red. So that would be read as 3x squared times 3x squared. Okay? So when we do that, well, I have to multiply my coefficients. What is 3 times 3?
9.
9.
Yep.
And here, I got to add my
X,
exponents. So
x to the power of 4.
Yeah. So now let's go back up to this part here. We're going to solve this one first since we just did it. It's fresh in our minds. What is 3 squared?
9.
Yeah, same as before. And what's x to the power of 2 times 2?
X to the power of 4.
X to the power of 4. And did you notice our terms are the same? Okay. And in this one here, negative 1 cubed is still negative 1. Yep. And x2 to the power of 3, or times 3, is x to the power of 6. Now, just like in this one, we had to multiply our coefficients. Because there is a negative 1 here, what's negative 1 times 9?
Negative 9.
That's right. And our bases, we keep them the same, and we add the exponents. What do we get?
To the power of 10.
That's right. There is our final answer in that question. Okay. So always be aware, I don't know where that came from, that our coefficients need to take on the value of our exponents too when they're on the outside.